Hello students, today we are going to learn about volume of a cuboid and cube. This comes under the chapter surface area and volumes. So here you can observe one aquarium. It is closed from top and bottom and from every side, and it is hollow. There is nothing in it. So it is filled with air. Now I have a small room and I want to keep this aquarium in my room. So I want to also calculate how much area will it occupy. To calculate the volume, so I want to calculate how much volume it occupies in my room. Now how we can calculate the volume, that we are going to learn in this chapter. Now what is volume? The volume of an object is the measure of the space it occupies. Now I have water. I poured the water in that aquarium, then till it is filled up to the brim. Now it's the maximum amount of water I can pour. If I fill it with water, then it is not called the maximum amount of water that I fill is called a capacity. In the definition, we can say that the capacity of an object is the volume of the substance its interior can accommodate. Now that can be any substance. I have provided example of water. Observe this figure carefully. From the look, you can make out that it is a cuboid. Now which is this figure? Is it rectangle? Yes. So now it is a page, rectangular page. If I stack up these pages one above the other, then it will look like this. Doesn't it look like a cuboid? Yes. So this is a cuboid. And this is how we can imagine a cuboid. Now, to calculate the volume, we have to calculate area of one such rectangle. Now, tell me what is the, if we keep the rectangle one above the other, what is the element that changes? What changes do you observe in this figure as compared to this figure? So only the height is changed, correct? So we have to multiply the height with the area of the rectangle. As you have learned earlier, area of rectangle is length into breadth. And if we multiply the height, then volume of a cuboid becomes length into breadth into height, which I have written L into B into H, where V is volume, L is length, B is breadth, H is height. Now let us look in the case of a cube. The only difference here is length and breadth are same. So we will not call it length or breadth, but we will call it H, and we will denote it by A. Now length into breadth is the formula for area of rectangle, and for the area of square, length and breadth will be H. So H into H. Here also the if we consider cube, then height is changed. So we will multiply the height to the area. So volume of a cube becomes area of a square face, which is H square, and into height. Height is also another H. So we will consider it H square into h, which becomes h cube. And since in the figure I have denoted one h as a, volume of cuboid is a cube, where v is volume. Okay, this is by mistake. I have written volume there, but we can write this as v of cube, which is a cube, and a is edge of the cube. Now we will look out for the units of volume for cube and cuboid. Now if we divide one big cube into smaller pieces, something like this. This is a Rubik's cube, and if we consider one square to be 1 centimeter cube, then 27 such squares will make up for the one big Rubik cube. Since each of these squares that we have divided are centimeters, so we can call its area as 27 centimeter cube. In similar fashion, we can do for the meter. So if this square, the smaller squares are made up of 1 meter cube, then 27 such squares would have made up for the 27 meter cube. So here the units would have been meters. So the unit for volume of cuboid is unit cube. Now unit can be centimeter, it will be centimeter cube, and in case of meter it will be meter cube. Now let's look out for some problems. A wall of length 10 meter has to be built across an open ground. The height of the wall is 4 meter and thickness of the wall is 24 centimeter. If this wall is to be built with bricks whose dimensions are 24 centimeter, 12 centimeter and 8 centimeter respectively, how many bricks would be required? So for that we have to write all the units given. Length is given as 10 meter, which is 1000 centimeter. So here you have to be careful with the units, because if you write one unit in meters and another unit in centimeters, then you will not get the accurate answer. That's why if you are using the meter, then you have to convert all the things into meters, and if you are converting into centimeters, then if you are using the centimeter unit, then you have to take all the measurements as centimeters. In this case most of the measurements are in centimeters, so we will take only centimeters, and all the units which are given in meter will convert it into centimeters. So 10 meter is 1000 centimeter, thickness is 24 centimeter, height is given as 4 meter, 1 meter is equal to 100 centimeter, then 4 meter becomes 400 centimeters. So therefore volume of the wall is equal to length into thickness into height. So length of the wall is 1000 centimeter, thickness of the wall is 24 centimeter, and height of the wall is 400 centimeters. So this is the volume of the wall. Now each brick dimensions are given as 24, 12 and 8. So length is 24 centimeter, breadth is 12 centimeter and height is 8 centimeter. So volume required for each brick, as we know that volume of a cuboid is length into breadth into height. So we substitute the values and we get volume of each brick. Now to calculate the how much the number of bricks required, we have to divide the volume of the wall with volume of the each brick. So here I have divided and we get this number. So these are the number of bricks required to build that wall. So you have to write the ending statement. So the wall require 4167 bricks. Now this is second problem. A child playing with building blocks which are of shape of cubes has built a structure as shown in figure. If each each cube is 3 centimeter, each edge is 3 centimeter, find the volume of the structure built by the child. So count the number of cubes in this structure. So they are 15. As we know that volume of cube is edge cube. So the smaller cubes have the edge 3 centimeters. So 3 into 3 into 3, 3 cube is 27 centimeter cube. Number of cubes in the structure are 15. If we multiply the area, the volume with the number of cubes, volume of small cubes into the number of cubes, we will get the volume of the structure, which is 405 centimeter cube. Thank you.